So for algebra 2 with trig, we're working on 14.1, 14.2b, graphing sine and cosine. The A value of our graph is the amplitude. We know that the amplitude is always a positive value. It also helps us decide if there is a stretch or a shrink in the graph. A vertical stretch or a shrink specifically, because that's a big difference for this type of equation. The B value helps us find the period. So the period is the degree value that it takes the graph to go through the full cycle. And our graph goes in increments, and the increment is going to be the period divided by 4. That is the increments. Another way you can find increments is pi divided by 2, pi over 2 divided by b. That's another way to calculate increments. I actually prefer period divided by 4. So what we're doing new today, we are including the H and the K. In our last lessons, we have worked with the A and the B. Now we're going to include the H and the K for our translations. There's a whole list of different rules that we could follow. We'll jump down and go right into some practice problems. One thing that we'll want to know about is our midline. The midline is the horizontal line that the graph is oscillating around. So that is always going to be, as it has been a lot of the year, this is going to be y equals k. So we come down here to our first example. Y equals a half cosine of 2x minus 2. We see that the A value is a half, the B value is 2, the H value is not part of this graph because there's no parentheses, and the K value is negative 2. So we can see all that just by looking at the equation. So the first thing we're going to do is calculate what the period is. The period is 2 pi divided by b. The b value is 2. So that's 2 pi divided by 2. So our period is going to be pi. That means it's going to go through that full cycle in pi degrees. Not pi degrees, but a pi angle. We can find our increments by period divided by 4. So that's going to be pi divided by 4 are the increments. So if you like to fill out the table, you could fill out the table starting with 0, ending with the period, because you know you've got to get to that point eventually. And our steps to get there is going to be pi over 4. 2 pi over 4 can be reduced. 3 pi over 4. And then our 4 pi over 4. When we're working with a cosine graph, remember the cosine graph starts at 1 and then goes to 0, then to -1, then to 0, and back to 1. The way we determine those is looking at your unit circle and using your coordinates that are part of the unit circle at the quadrantal angles. Cosine are x values. So we start at 1, then we go to 0, then we go to -1, then we go to 0, we go back to 1. So those are all parts of your unit circle working at our quadrantal angles. I know those aren't matching up with the particular angles, but that's because we're shrinking our graph together because of the p-value. So we could come over, we'll use our increment values to write our scale on the x-axis. So if you'd like to zoom in and be able to see that, we've got pi over 4. Then we've got 2 pi over 4, which can be reduced to pi over 2. 3 pi over 4. And 4 pi over 4, which can be reduced to just pi. So we first find the period, we find the increment, and then we label that increment onto the graph. So using our equation, it says that the parent function would be cosine, so 1, 0, -1, 0, and 1. So that's our y equals cosine of 2x. We label it as 2x because we've already changed the x scale. So we need to be sure to call this 2x. Remember that the scale is being affected by the reciprocal. So the 2x, the 2 is actually making it half the size. So instead of going out to 2 pi, we only went out to pi. So then we're going to work through our RST. There is no reflection. There is no R. The S is a shrink. So I did not leave myself much room, but we could be at the halfway location, and 0, half of 0 is a 0, half of -1, half of 0. Sometimes we change our scale to make it twice as high so we could easily take half. I did not in this case. So half of cosine of 2x. So that's our graph so far. And the last part we haven't looked at is the k value. The k value is -2. That means we're going to take all of our green dots and drop them down 2. So 1, 2, 1, 2, 1, 2, drop them down 2. And there's our graph, y equals 1/2 cosine of 2x minus 2. By looking at this, we can see that the amplitude is really small. It's a half. It's the absolute value of your A is your amplitude. The period we already calculated was pi. And the midline, that is your k value. That was y equals -2. Next, we could talk about what are the points on the graph. Okay, this could be handy in a few questions. So we list points for the graph the same way you would do any type. So we have 0 right and left. We're down 1.5, which you could call that 3 halves if you want to get technical. We're over pi over 4, and we're down 2. So that would be -3 halves for that one and -2 for this one. We have another point over here, which is out at pi over 2, and we're down 1, 2, 3, 4, 5 over 2, and that's negative. And we've got another one at 3 pi over 4. And we're down at -2. And then our final point out there is at pi, and we're down at -3/2. So those are the actual coordinates that we plotted. You could develop a table along the way to support those, or we could graph them by figuring out our increments and shrinking it, translating it, and then we can identify our points. So this next one, I'm going to show you a little bit quicker way on graphing it. Okay, it gets a little tricky sometimes. Maybe you prefer to do the whole parent function first, take your time, work through it. But we can't do anything but find the period. So we still have to do 2 pi over b. That's 2 pi over 1/2. When you're multiplying by 1/2, or actually dividing by 1/2, that's the same thing as multiplying by the reciprocal. So our period is going to be 4 pi. So we're going to start at 0 and go all the way out to 4 pi is the length of the cycle. We're going to have something a little bit different because we have a translation involved. So next we have our increment, which is the period divided by 4, which is 4 pi divided by 4, which the increment is going by pi's. So we have 0, and then we have 1 pi and 2 pi, then of course 3 and 4 pi. If we look at our equation, we see that there's going to be a translation to the right because this is x minus. It's going to translate to the right. So we're going to have to do 3 more of these pi's. So I could list them now if I like, 5, 6, and 7. So we labeled all the pi's, even 3 additional ones, because that's what our scale is going to require. And then we're recognizing that we are graphing our sine. Okay, your sine graph would typically start at 0, 0. But if we're going to translate it, here's your shortcut. If you're going to translate it 3 pi to the right, we're going to go 3 pi to the right. There is no k value. So we're going to start right there. Now we're going to do our normal sine graph that is stretched by 2. There is no reflection. It doesn't go upside down. It's just a stretch of 2. So instead of going up 1, we're going to go up 2. Back to 0, go down 2, and back to 0. There's our sine graph. So y equals 2 times sine of 1/2 x minus 3 pi. We graph the entire equation onto the grid in essentially one step. We didn't do the parent, the stretch, the translate, which is just fine. You can break it into the separate steps. We see that the amplitude is your absolute value of A, so it's 2. The period, how long does it take for it to reach throughout the entire graph? Actually, it's called the entire cycle because the graph does go on forever, right? It does continue on. But the cycle until it repeats again this is what we saw, 4 pi. And our midline is right on the x-axis, so that's called y equals 0.
So why did you start at 3 pi?
We started at 3 pi because that was our h value. We have our h value, which translates a graph. I would have originally started over here and gone up 1 into 0 and -1 and back to 0. And then we would have stretched it, would have gone twice as far. And then we would have moved all those points 3 units, 3 pi to the right. Minus means right. It's minus a positive number, and that positive number is telling us to go to the right. All right, let's try this next one. We're going to start with the period. Always start with the period. So we have 2 pi divided by b. The b value is found in front of the x. So 2 pi divided by 4. So that can be reduced to pi over 2. So now we're going through our full cycle in a pi over 2 step. And that's going to be very, very quick if we were to see it condensed like that. But because we're graphing it kind of using the same scale of 4 lines, it's actually going to physically look the same as most of the other ones. But it is going through the cycle very quickly. So we'll do our increments. Our increments is the period divided by 4, which is the pi over 2 divided by 4. So when you divide a fraction by a number, you have to multiply by the reciprocal. So we actually get pi divided by 8. So this is where it is pretty clear that we are getting through the graph much quicker, is because we're writing pi over 8 rather than typically a pi over 2, or even the last one, which was a full pi. We're going to make our first step in pi over 8. 2 over 8 would be pi over 4. 3 over 8. And 4 over 8 is pi over 2. And of course, that has to match what the period is. The period is pi over 2. That's going to be what our 4 steps are. We don't have to worry about extending this one out because there is no h value. There are no parentheses around the x. There is no translating right or left. This is translating up. Since it translates up, we'll put in our midline, make that dashed. We like to label that as y equals 1. Then we get ready for our graphing. This is a cosine graph. Pay close attention to that. Don't mistakenly graph a sine. This is cosine. That brings its own challenges. Cosine typically starts 1 unit up, but because it's reflected, we're going to start 1 unit down. So that would be over here. Oh, not exactly, sorry. It's 1 unit down from our midline. This is where it gets tricky when you're trying to do the translations all in one step. So we're back to 0, then we're to +1, then back to 0, and then to -1. So try to get there to be some flow to that graph. And this is y equals negative. That's why it's upside down. Cosine 4x is what made our scale on the x-axis +1. We translated it up 1. So again, I did that graph without starting with the parent function. We graphed right into it. Can be a little challenging. If you prefer to show the parent function and then reflect it and then translate it, that would be just fine.
What's
In the equation, the 4 in the equation is your b value. That's what we plugged in here for our b value. The 4 of the equation is in front of the x. That is affecting the shrink or stretch of the graph. And it's always going to be opposite kind of what it looks like. It looks like it's 4 times bigger because it's a 4. The bigger the number, the more it's getting condensed. So it's the reciprocal. So 4 makes it condensed by, it's 1/4 the size. Okay, it takes 4 of them to match a full typical 2 pi. The amplitude we saw is the distance from the midline to the maximum or the midline to the minimum. That is 1. It's the absolute value of your A. The period, we already calculated that. That was pi over 2. And the midline, that's your K value, y equals K. I'm sorry, it is the K value. That is y equals 1. You go ahead and try this one. If you're following along with the video, you can pause it and try to graph it out yourself and then come back and experience it first time. So as we look through this equation, we see that the A value is 5, the B value is 1, the H value is pi, and the K value is 1. We haven't talked about those for all the examples, but those are good things to be able to recognize, identify. Each one of those does a different aspect to the graph. So we're going to look at the period. The period is 2 pi divided by b. That's 2 pi divided by 1. Of course, that's 2 pi. That means it's going through the graph at the same speed it always would from the parent function. The increment is the period divided by 4. So 2 pi divided by 4 is pi over 2. Well, that's not a surprise. We should be going back to our pi over 2 for each step because the period is 2 pi. So we have pi over 2 and pi, 3 pi over 2 and 2 pi. Since there is a translation, notice how this is x plus pi. That means there is going to be a translation to the left. So you may want to put those values in now, negative pi over 2 and negative pi. We're taking 2 steps to the left. We have to go all the way out to pi to the left because it's x minus a negative pi, which makes it look like x plus pi. We know that there would be a midline at +1. So you can come up here and put your midline in at +1. We're going to be stretching our sine graph by 5, and we're going to be starting it at negative pi. So there we are at negative pi. We're going to stretch it by 5. So instead of going up 1 unit, I'm going to go up 2, 3, 4, 5. Then I go back to 0, which is just back to 1. I come back to my midline. And then I would be down 5 from the midline. 1, 2, 3, 4. and then back up. Notice that I'm going from negative pi out to pi, so that's a total cycle of 2 pi. So we get y equals 5 sine of x plus pi plus 1. Did we have a reflection? Was there a negative on the a value? None. There was no reflection. Was there a stretch or a shrink? All right, there was a vertical stretch. By scale factor of 5. We vertically stretched it. We did not have any horizontal stretches involved. The translation was pi left and 1 unit up. Left pi, up 1. That was the translation. The amplitude is your a value. It's actually the absolute value of the a value, but that's still going to be a positive 5. The period we knew was 2 pi. We can tell that because we start at negative and we work our way, negative pi, we work our way out to 1 pi. So it's 1 to get to 0, and it's again to get out to pi. So 1, 2, 2 pi. We calculated that right here. The midline we saw was our k value, so that's y equals 1. Oh, I did land short of that, didn't I? That's kind of silly. Get so used to landing on the x-axis. We should go all the way to that midline. Good work. Thanks for noticing. So what are our coordinates? Let's work on that coordinate writing again. We have this first point that's out here. That's negative pi for your x, and it's up 1. So that is one of the coordinates that we had on our graph. We have another coordinate on our graph, which is negative pi over 2, but that is up 1, 2, 3, 4, 5, 6. It's up 6 because it's 5 above the midline. The third one was at 0, 1. The fourth one was at pi over 2, 1, 2, 3, 4 down, which is 5 units from the midline. And the sixth point was out here at pi, comma 1. So those would be your coordinates that represent your graph. Number 5. I'll have you work on this one. You can pause the video. You can come back to it. All right, looking at number 5. We calculate the period. Let's do that down here. Period equals 2 pi divided by b. The b value, well, let's say the a value is -1. The b value is 1. The h value is pi. The k value is -2. So the b value we said was 1. So it's 2 pi. That means the increment, which is going to be the period divided by 4, is going to be pi over 2. So we'll put our pi over 2 and 2 pi over 2 and 3 pi over 2 and 4 pi over 2. Now I notice that my h is pi. It's a positive number. It's x minus h, and the h, because it's a minus, it moves to the right. I'm going to have to go a whole nother pi. So this should be 5 pi over 2 and 6 pi over 2. So now I'm all the way out to 3 pi. If it's a little confusing, especially with the cosines, I find that to be a little bit more challenging to visualize what has to happen. Maybe it would help you just to start with the normal cosine graph. There's your cosine graph. So y equals cosine of x. We graph that. Then we would reflect it. So that's going to be y equals negative cosine of x. Then we're going to translate it. To translate it, we're going to move pi to the right and 2 units down for every dot. Pi is 2 steps to the right and then 2 units down. We would typically want to put in our midline as a dashed line through the horizontal of -2. So there, I showed it to you more in an RST format. I believe I took this and I went pi over 2, and then I went pi. So I took 2 steps to the right, but I went 1 pi. It's 1 pi to the right, which is actually like 2 steps, and then it's 2 units down. However you want to think about that. Okay, the reflection, reflection over x-axis. We didn't have any type of stretching. We translated pi right and 2 units down. The amplitude was 1, the period was 2 pi, and the line was your k value, which is -2. So flip the page. We have one more specific example to do, and then 2 you tries. You've kind of been trying on your own here for a few of them anyway. Because once you know how to get the flow, you're going to do just fine. So I'll do this one for you. If you want to work at it at the same time, that is awesome. It looks again that the period is 2 pi because there is no b value. The a value is -2, the b value is 1. The h value is -pi over 2 because it's always the opposite of what it looks like. The formula is x minus h. So if this is a positive h, positive looking, plus h, then the h must have been a negative to have x minus a negative to show it as a plus. The k value is a 3. So we could start, if we're going to do this all in one magical step, sine's a little bit easier to do that with. We could go up. Oh, we needed to do our increments. Let's do that also. Increment is the period divided by 4, which is pi over 2. So we could say pi over 2 and pi, 3 pi over 2 and 2 pi. I'm going to translate to the left. So I'm going to involve that right now. I'm going to put the negative pi over 2 in our graph. So probably working backwards, maybe you would think about it like that. We're going to do our k first. So we go up to 3. That's our k value, y equals 3. From that, we're going to look at our translation. We're going 1 unit left, which is the pi divided by 2 to the left. We are going to stretch it by 2. So instead of going up 2, we're actually going down 2, and then back to 0, and then up 2, then back to 0. And that's our equation, y equals -2 sine of x plus pi over 2 plus 3. We have a reflection over the x-axis. We had a vertical stretch by scale factor of 2, and we translated pi over 2 left and 3 units up. The amplitude is the absolute value of A, so it's 2. The period we calculated is 2 pi, and the midline is your K of 3. And that is that.